Hi everybody, it's Miss Austin and I'm going to be going over this worksheet on sequences. We are reviewing arithmetic and geometric sequences and we are looking at how to write them recursively and explicitly. So for number one, we have to generate the first 5 terms. Letter A, we've been given a recursive rule. I can tell because it has 2 parts. It gives me the first term and then it tells me some information. So it says the first term is 4. And then what this says in a sentence, right? This says to get any term, you add 6 to the previous term. This means previous term. So to get this term, I'm going to add 6 to the one before. So 6 plus 4, 10. To get this term, I'm going to take 6 to the one before. That's what that's saying. Okay, so once you understand that, it makes it a lot easier. So I'm just moving along here, adding 6. There's my first 5, and then in sequences we go dot, dot, dot. Okay, this is an explicit rule for letter B. Notice how they don't tell me the first term. Now, some people can get good at understanding and they can tell what the first term is. I'm going to teach you how you can just plug in numbers and generate the sequence in case you don't understand what the rule says. So this says 5 plus 2n for n is greater than or equal to 0. This is telling me where to start. Sometimes in a sequence, they could call this the first term. They can also call it the 0 term. And we want to be able to handle both of those things. So here, they're saying start with the number 0 and plug it in. So if I put a 0 in there, 2 times 0 is 0, 0 plus 5, there's my first term, or my 0 term. Now I'm going to plug a 1 in, right? Plug a 1 right here. 2 times 1 is 2, 2 plus 5 is 7. Now I'm going to plug a 2 in. 2 times 2 is 4, 4 plus 5 is 9. Now let's take a step back. Can we see what's happening here? That was the 0 term, and it looks like I'm adding 2 every time. Now, you don't have to be able to decode these, but it's just sort of interesting to notice those things. See that? It's adding 2 every time. All right, letter C, we're back to another recursive rule. It's got 2 parts. It flat out tells me the first term. And then it says to get any term, you take the term before it and multiply by 3. So to get this one, I take the one before it and I multiply by 3. I take the one before it and multiply by 3. I take the one before it and I multiply by 3. I take the one before it and multiply by 3. Okay? Again, I'm going to emphasize this G of n minus 1, that means previous term. All right, last one, we've got another explicit rule. It says R of n equals 5 times 2 to the n minus 1 for n is greater than or equal to 1. So they want me to start with the number 1. They're calling the first term of the sequence the first term. So if I plug a 1 in there, 1 minus 1 is 0. I'm going to write this out. 5 times 2, if I put a 1 there, I get 0. A lot of students forget that 2 to the 0 power is 1, and 1 times 5 is 5. Now I'm going to put a 2 in there. 2 minus 1 is 1. Okay, when I put a 2 in there, 2 to the first is 2. 2 times 5 is 10. Now I'm going to put a 3 in there. If I put a 3 in there, 3 minus 1, now I get 2. 2 squared is 4. 4 times 5 is 20. Maybe we could see what's happening here. It looks like I'm multiplying by 2 every time. See that? So the next one would be 40. The next one would be 80. Dot, dot, dot. Okay. So hopefully you know how to generate a rule or generate a sequence based on the rule. The next 3 are story problems, but they're sequences, and we're going to be writing the recursive and the explicit rule. It says the height of the water level in a tank is 200 inches. The water level increases at a constant rate of 10 inches every day. H of t is the height of the water level after t days. H of 0 equals 200. So they're calling this the 0 term. Write the recursive and explicit rule for t is greater than or equal to, we should actually call this, let's call this, sorry guys, I'm going to change this. It should be the same thing. We'll call that h of 1. Actually, no, we do need to keep that 0 because after 1 day, so this should be 0. Okay. So here we go. So recursive rule, we state the first term, h of 0, because that's our first term. We're calling it the 0 term. No days have passed is 200. And then to get any term after that, what do? We add 10 to it. It's adding 10 every day. So we take, and you can put the 10 before or after. So you take the term before it, that's how you say the term before it, and you add 10. Okay? So if I want the first term, right, starting at 200, that's called the 0 term. If I want the next one, I take the one before it and add 10. 210. If I want the next one, I take the one before it and add 10. Okay, that's the recursive rule. Now, explicit. I'm going to come over here. I'll kind of block this off. The explicit rule, we do not flat out give the first term. So we say h of n equals, and this is kind of the recipe to write these. You're going to give the first term, even though we're calling that the 0 term, it's okay. We're going to say 200 plus, what am I doing every time? I'm adding 10, and since we're calling this the 0 term, we're going to have to put just n, right? And we're starting greater than or equal to 0. Now, in a real life problem, it makes sense to call the first term the 0 term because the water at the beginning was 200. No days had gone by. That was on like the 0 day. So if you can imagine, if I put a 0 in there, 10 times 0 is 0. And so the first term is 200. Then if I put a 1 in, okay, there's my explicit rule. Explicit, recursive. All right, next problem. The first row in a theater has 8 seats. The second row has 11. The third row has 14, and the fourth has 17. F of R equals the number of seats in row R, and F of 1 equals 8. Write the recursive and explicit rule for R is greater than or equal to 2, which describes the number of seats. So I'm going to write this out. So we have 8, 11, 14, 17, and they're calling this the first row. See how they call it F of 1 this time? Okay, so you can't get caught up into this 0 term, first term. It just kind of depends on the problem. All right, so let's write the recursive rule. Here we go. Not a lot of room here, guys. Sorry. So here's recursive. So I give the first term. Here it is. F of 1 equals 8. And then what am I doing as the number of rows increase? I'm adding 3 every time. So I say to get a term, you take the term before it, that's how you say previous term, and you add 3. There's my recursive rule. 2 parts. All that says is take 3 to the one before it. 3 to the one before it. Okay, now let's write the explicit rule. So we're going to put the first term, which is 8. We're going to write F of n equals 8. What am I doing each time? I'm adding 3. This time, since I'm calling that the first term, right, I want to add 3 over and over, but I don't want it to do it on the first one. So I'm going to say n minus 1. And we already know what the first row is. So it says for R is greater than or equal to 2. Oh, they called this R. I put N. Sorry, guys, it doesn't really matter. So now look, if you put a 2 in there, 2 minus 1 is 1. 1 times 3 is 3. 3 plus 8 is 11. That gives me the second row. For the third row, I'd put a 3 in there. 3 minus 1 is 2. 2 times 3 is 6. 6 plus 8 is 14. Here's my explicit rule. And keep in mind, guys, when you take your Performance Matters test later this week, it's going to be multiple choice. Okay? All right, last one. The 13th row in a theater has 41 seats. The 12th row has 38, the 11th has 35, and the 10th has 32. F of R equals the number of seats in row R. F of 1 equals 5. Write the recursive and explicit rule. Okay, well, let's see. They give us the first term, but then they don't give us one until like the 10th row. So I'm just going to look at what they give me. They give me the 10th has 32. The 11th has 35. I'm going backwards because they gave it in backwards order. This was the 10th row, the 11th row. The 12th row has 38, and the 13th row has 41. So even though they didn't give me like the second and third term, I think, look, can we see what's going on here? Yeah, they're adding 3 every time. And it's starting, the first row has 5. Okay, so now we're going to write the recursive and the explicit. So my recursive rule always has 2 parts. I give the first term. And then what do I do as I hop along here? As I move from row to row, I add 3 more. So you say to get the next term, you add 3. I'm going to put it in front this time. 3 plus the row before. All that means is the one before. Add 3 to the one before. Add 3 to the one before. And those together tell you what to do. Okay? And then the explicit rule, we don't flat out tell the person what the first term is. We write a general rule that can find any term. So we're going to write f of n equals, we know the first term is 5. And what am I doing over and over again? I'm adding 3. But they want me, right? They're calling this the first term. So I don't want to add 3 the first time. So I say n minus 1. Okay, does that make sense? Because if I just put an n there and I put a 1 in, 3 times n is 3, or sorry, 3 times 1 is 3, and 3 plus 5 is 8. That wouldn't give me how much was in the first row. So I need the n minus 1. Now look, if I put a 1 there for row 1, 1 minus 1 is 0. 0 times 3 is 0. There's 5 seats in the first row. Okay? And they don't even want me to start with row 1. They're saying for n is greater than or equal to 2. Okay? I hope that helped. There's going to be some more review problems Thursday or Friday, whichever day you have class, followed by 2 quick sequence check-ins on Performance Matters. I hope you have a great day.